Hello, my dear 10th standard lions. Very warm welcome you all to the discussion Magnetic Effects of Electric Current, which I am calling in short magnetism. And mainly in this video, I am focusing on magnetic field of a bar magnet, magnetic field lines of a straight wire, magnetic field lines of a circular coil, magnetic field lines of a solenoid, and right hand thumb rule related questions also. These are the main thing which I am focusing on this video. So let's get into the topic. The first topic I would like to discuss with you, magnetic field and field lines. It is two term, right? So first of all, what is magnetic field? Everyone know what is magnetic field, I'm sure. Because that's a very common word, right? Magnetic field. You start seeing the magnet from childhood onwards, right? Okay. So what do you mean by magnetic field? Before it, can I ask a question to you? What do you mean by gravitational field? Or leave it. What do you mean by electric field? What do you mean by gravitational field? Come back. What do you mean by gravitational field? The region around the planet where the gravity is experiencing, in simple man language, right? The gravity felt region is called what? Gravitational field. Okay. We can discuss later more about that one. What do you mean by magnetic field then? Field means just a region. If I use a perfume, then around me, some good smell you will experience, right? That is called my perfume field. Similarly, around a magnet, we will experience a magnetic force of attraction or repulsion. That region is called what? Magnetic field. Simple. Once again, what is magnetic field? The region around a magnet or a current carrying conductor where the magnetic influence is experiencing. Magnetic influence means force of attraction or repulsion experiencing. That is called a magnetic field. In exam perspective, definition of magnetic field, they are not usually asking. Everyone know that. But the problem is that magnetic field lines. What do you mean by magnetic field lines? Okay. So let's get into the topic of magnetic field lines in little detail. That's our exam corner. Okay. So what is my magnetic field lines? So let me draw a bar magnet here. Let me consider a bar magnet here. A bar magnet have two poles, right? North and south. So there are some region around this bar magnet where its force is felt. That region is called what? Magnetic field. So if I represent the region like, oh, this much region where the force of attraction or repulsion is experiencing. Let me say to you, this much region, the force of attraction or repulsion is experiencing. So this region is called magnetic field. Is it this representation is fine to you? Will you agree to me? You never agree me, right? Why? This representation is not scientific representations. Why this is not scientific representation? Because this kind of boundary representations good for map and all, but this is not good for to plot magnetic field, represent magnetic field. Why? Because this doesn't tell like where the force of attraction is more, where the force is like weak, which point on the magnet force is more, force is less, etc. Doesn't tell, this kind of lines. Okay, so we need a scientific way of representation of magnetic field. So that means this is wrong representation, right? So how do we represent the magnetic field strength around a bar magnet? We'll use a set of line which is, we call it as magnetic field lines. So then, what is the official definition of magnetic field lines? If they ask, they're usually asking one more question, define magnetic field lines. What you will write if they ask define magnetic field lines? It is an imaginary line. It's an imaginary closed curve. Little more beautifully, I say it is an imaginary closed curves used to represent the strength of magnetic field of a magnet. What is that? Repeat with me. It is an imaginary closed curve used to represent the strength of magnetic field. That is what we called magnetic field lines. Agreed, right? Okay, that's one more question. Keep in your mind. Now, let me tell you, how do we draw the magnetic field lines? Is there any rule for it? Yes, it has a rule, is there? Yeah, that is to define the magnetic field lines diagram, we require to know first what is compass. You know what is compass, right? Yeah, compass is actually consisting of a tiny magnet. It consists of a tiny magnet and it has two needles, right? It has two needles. So what I am doing, I want to draw the magnetic field lines of this bar magnet. So I kept a compass near to it. Then compass have two poles, north and south. Which pole comes here for the tiny compass needle? South will comes here, right? Why? Because we know south only attracted to the north. So south will comes here and north will comes here. So let me mark the north point. When I kept a compass here, I can mark what? The north point of the compass needle here. All right. So I got 1 point. Then I taken the compass from this position, then placing the compass in the next place. So again I am marking the next north point indicating line. The compass I kept here, the north pole will point this way. I marked that north point. Similarly, I will do like a couple of points. Like what this dot? This dot is actually, if you keep a compass here, north pole of the compass pointing directions. I keeps on mark that north pole pointing direction. Finally, you can see I come across the south end. I get a set of lines. I get a set of points, right? If I join all this point together, what I am getting, that is what we call it as magnetic field lines. So I told you what is the definition of magnetic field lines. What's the definition of magnetic field lines? It is an imaginary closed curve used to represent the strength of magnetic field. Yes, you agreed, right? You're happy. The next one, how do we draw the magnetic field lines? By using compass. By using compass. What's the method? This is the method. Like keep the compass everywhere, mark the north pole pointing, directions. Then finally you can join all of them. You will get what? A beautiful line, which we call it as magnetic field lines. And similarly, repeat the procedure in every place. I will show one beautiful diagram, okay? This is a rough diagram to you. So this is the another magnetic field lines. Similarly, we can draw many lines everywhere by using the compass. This is called magnetic field lines. And which way the north pole of the compass is walk here? Yeah, this way it is walk, right? This way the north pole of the compass walk or runs. So that is the direction of magnetic field lines. Finally, the north pole of the compass is like meet its lovely partner, which is called the south pole. Okay, finally you can imagine like the north pole of the compass coming and close and attracting towards the south pole. So it is merging towards the south pole. So this is what the magnetic field lines picture of a bar magnet. You got the concept of this? Okay, this is the magnetic field lines of bar magnet. That's agreed, right? Okay, fine. Okay, Rafi sir, then you said that it is a way of representation of strength of magnetic field, right? Yeah, it's a way of representation of strength of magnetic field. How do we know that? Yeah, if it is like more magnetic field lines are more crowded, then we can say it's more strength. That region is more strong magnetic field existing. I will tell you the properties. Wait, you got the 2 points, right? What is magnetic field lines? How do we draw? That's only you want to aim in this discussion. That is done? Okay, agreed. Then one more thing you want to remember, inside the magnet also magnetic field lines are there. We'll draw like a dotted line, which is from south to north. Inside out is south to north. Outside it is what way? North to south. This is the magnetic field lines of a bar magnet diagram. All right. Then it comes to next question. Wait, before it, we want to learn the properties of magnetic field lines. We want to learn the properties of magnetic field lines, which is important. Now I told how to draw the magnetic field lines of a bar magnet. Then what are the properties of magnetic field lines? Oh, before it, magnetic field lines have one more beautiful name is there. One more nickname is there, which is called the magnetic lines of force. It is called the magnetic lines of force. Magnetic lines of force. Magnetic field lines का दूसरा नाम क्या है? Magnetic lines of force. All right. Yeah. Now, what are the properties? I'm writing the properties in short here. Okay, properties. Easy scoring area. Don't miss out this one. Everyone must learn. What are the properties of magnetic field lines? Property number one, magnetic field lines, outside the magnet, I'm writing here shortly, outside the magnet, it is from north to south. Which is the direction of magnetic field line outside the magnet? North to south. While inside the magnet, south to north. That is one property. Okay. Then second property will be magnetic field lines are always a closed curve. It's a closed curve. It's a closed curve. There is no gap in the curve. Look at this. It is a closed curve. It's a closed curve. Okay. Then third point will be magnetic field lines never intersect each other. What's the point? Magnetic field lines never intersect each other. Never intersect. Okay. Never intersect each other. Magnetic field lines never intersect each other. Then the fourth point will be the closeness of the field lines indicate the strength of the magnetic field. The closeness of the field lines indicate the strength of the magnetic field, or crowdedness of the field lines indicate more stronger is the field indication. Okay. If you assume, like, if you and your friend is walking, just assume in a path, you and your friend is walking, and you are like, you are actually holding the friend, like, very closely and tightly. Then what another person who observing you will say? They will say, oh, that two guys are like in very strong relation, right? If you and your friend is like walking like very close manner, then what you will say? What's observation? What's the inference? We'll say that you are like very thick relation, very strong relation, right? What if you and your friend is walking little apart? What people will say then? People will say they are not in that much relation. Weaker is the relation. In that logical sense, if the field lines are, very close, then we can say there is a strong magnetic field exists. If field lines are little gap is there, then we can say it's a weak field. So that's actually the fourth point. You can logically connect. Closeness of the field lines indicate the strength of the magnetic field. Okay, what's the point? Closeness of the field lines. Closeness of the field lines, let me write here, field lines gives the strength of magnetic field, gives the or indicates the strength of magnetic field, strength of magnetic field. That's fine. Okay. Now here is a question, always asking questions. Always asking one fundamental question. I hope you all know this. Anyway, let me repeat. Why do magnetic field lines not intersect each other? Why we are saying magnetic field lines never intersect each other? If you got the concept already, how do we draw the magnetic field lines and all? Definitely you can think about it. If you are not attended, if you are not learned this one before, can you pause the video and try to figure out? All right, look here. What if magnetic field lines intersect? Let me use two color, okay? What if two magnetic, what if two magnetic field lines intersect each other? Yeah, if two magnetic field lines intersect each other, or before it, how do we get these two field lines? By keeping compass, right? By keeping compass, okay. By keeping compass. So when I keep compass here, yellow line said that compass will point this direction, okay. Black line said that compass will point this direction. Oh, I got confused. At that point, compass only point one direction. How it is possible to point compass in two directions at a place? It is not possible, right? That is not possible. You got it? Think back. Once again. How we got this yellow magnetic field lines? By keeping compass. How you draw the black magnetic field line? By keeping compass. Which means if I keep the compass here, yellow magnetic field line said that compass will point this direction. Black said that compass will point in that direction. Can a compass point multiple direction at a place? No. If I stand here, I can only focus on you. I can't focus, the same time another directions like this. It's not possible, right? Because I'm not God. Similarly, compass also not God. It can only align in one direction. That's the reason why this is not possible. So magnetic field lines never intersect each other. Okay, sir, we understood. Happy. How do we present exam? You can present like this in exam. Fine. It's a statement. Just read it. Okay. Copy down the content in your book. Very simplest explanations. All right. Let me move to the next point. Here it is the whole magnetic field lines picture. all the 10 standard magnetic field lines picture. You can take a screenshot with me and Excel together. Okay, yes, the complete magnetic field lines diagram for a 10 standard students to learn. One is for, bar magnets. Other one is for the straight wire, magnetic field due to a straight wire. Other one is magnetic field due to a solenoid. Other one is magnetic field due to a circular coil. I'll come in detail to every point. Just listen this diagram. Must practice it, okay? Must practice 1 or 2 rounds to make a good and beautiful diagram. So here comes the point, magnetic field due to a straight wire. Straight wire. Can you pause the video and try to figure out how do we get magnetic field lines direction around a straight wire? Can you guess the name of the rule which is used to find the direction of magnetic field lines around a straight wire? All right, I am sure that you've said magnetic field lines direction of a straight wire is governed by Maxwell right hand thumb rule. Don't worry, you might learn like right hand thumb rule, it is enough, but it's more beautifully Maxwell right hand thumb rule. Right, you know that, right? The direction of Maxwell right hand thumb rule. So it is stated like this, right hand thumb rule. So it's easy content. You already know this one. So this is the official definition of right hand thumb rule. Keep in your mind, right hand thumb rule, they asked to explain. When they ask to explain, you can make a good sentences, okay? You can use like this kind of sentence. Hold this straight wire in our right hand such that thumb should be along the current direction. Then how this all wrapped fingers going? That gives how your 4 fingers going runs around the straight wire. That's actually the magnetic field direction of a straight wire. Let's solve a couple of numericals of right hand thumb rule. Here it is, the first question. Can you pause the video and try to figure out yourself one round? All right. So here current is going in east direction. What is the direction of magnetic field below the wire is asking. What should we do? This kind of questions when we get. Yeah, you can do one thing. You can assume like your front of you like taken as north and back is taken as south. Right of you considered as a east direction. Left of you considered as a west direction. All right. Then here current is going in east direction. So let me take my pen pointing towards the east direction. This is actually the current, okay? Current indication. All right. Then how do you find the magnetic field directions? By using Maxwell right hand thumb rule. So step number 1, hold this straight wire in your right hand such that thumb should be along the direction of current. Hold like this. Don't hold this way. Why? Because thumb is pointing towards west side here. But here, thumb is pointing should be the direction of current. Current is to the east. So I want to hold like this. It's a correct holding. Fine. When you do this, then what Maxwell said, that is this all curled fingers gives the direction of magnetic field. So here the curled fingers run this way. So magnetic field around the straight wire is run this way here. Okay. So I'm going to use my one of the finger to move along the magnetic field direction here. Okay. Like this is the way the magnetic field is going. All right. When you look the side view, it will be like this. Okay. So you can see, but I here want to find magnetic field below the wire, right? So I'm going to stop my finger below the wire. That time, how the finger is pointing? It's pointing towards north side of me. Okay, so front of me. The finger is pointing towards the front side. That is what we called north. So over here, magnetic field is towards north. Okay, so the answer is magnetic field is towards north. Got it? You can do this questions like various way also. But what if the question asks like above the wire? What will you do? Move your finger around this curled finger. If you want to find on the top, then stop your finger on the top. The finger is run this way, right? So if you want to find on the top, stop the finger on the top. Then finger is pointing towards me. That's not towards me. It's back of me. That is south. If they ask on the top, it is towards south. I hope you understood this. Try to solve this yourself, okay? Now, let's solve one more numerical of right hand thumb rule. Here it is the question. Can you pause the video and try to figure out yourself one round? All right. So here it is a question. Electron is moving from ceiling to the floor. Okay, electron is coming like this. Oh, we can welcome the electron. Electron is coming like this. Okay, this way electron is coming to the down. Question is asking then what will be the magnetic field on the right side of you? Okay, fine. It's a little tricky, but we can break. Listen. Electron is, going down. Then what will be the current constituted by electron direction? Yeah, we know that current and electron flow are opposite direction. Current is always opposite to the flow of electron. Okay, so electron is going down means current is upward. Agreed. If electron down, current up. We don't care about electron. We need current. So current is up. Fine. So over here, now let me take the pen. Current is up, right? So let me keep the pen like upward, pointing up. So this is the current carrying wire now. Fine. We need to find magnetic field on the right side. Okay. Step number 1, hold this straight wire in our right hand. Number 1 step is done like this. So how the fingers are going? How the fingers are going around the straight wire? It's going like this, right? Okay, so I'm going to move my finger around this. Okay, I'm going to move the fingers around this curled finger. Oh, it's like this. Oh, it's a little bit exercise to me. Okay, anyway, I will try. Yeah, it goes this way. Okay, fine. So, we require to find magnetic field on the right side. So, I'm going to stop my finger on the right side. That time, how the finger is pointing from my face to the front wall. What I called before the front wall? North of me. So, the answer is towards north. Got the idea? Now, let's focus another most important part in this chapter, which is called solenoid. If you start observing the last few years question paper, solenoid is the most important topic. You guys can surely get a question from solenoid this year too. Okay, fine. So, what is solenoid? Solenoid is a coil. Let me draw here. A coil which consists of many turns wrapped closely in the shape of cylinder. So what is solenoid? What's the answer? What's the definition for it? A coil of many turns wrapped closely in the shape of cylinder. That is called a solenoid. Keep in your mind this definition. What is solenoid? They are usually asking questions. So like a spring, like a coil, okay? And see here, let me draw a current carrying solenoid. So current carrying solenoid, it's a current carrying solenoid. Fine, that's what the solenoid. Draw the pattern of magnetic field lines of a current carrying solenoid. That they were asking the first. You saw the pattern before, right? Magnetic field lines of a solenoid. I show the all magnetic field lines of a bar magnet and solenoid. You can go back and check it, that field lines diagrams. Okay, so that's important. You learn it. Okay, magnetic field lines of a solenoid and a bar magnet. Then, what is the distinguishing features between two field? Two field of what? Two field of bar magnet and solenoid. All right. So here it is asking, what is the difference between magnetic field of solenoid and bar magnet? Listen before one point, all of you. If you take a solenoid, let me draw the solenoid. Look at the way in which I am drawing the solenoid. It goes up and coming down like this, na? Okay. This is what? A solenoid. This is a current carrying. Let me attach a battery for getting current. When the battery is closed, when the key is closed, how battery can close? When the key is closed, then current start flows from positive of the battery. Like this. Current start flows from positive of the battery. Like this. How the current is going? Yeah. Do you see that? Come with me. Life is adventure. Come on. It's going up and coming down. So what type of current this one? From my side. It is like clockwise. So if the current is clockwise, then that end of the solenoid is like a south pole. How will you mark the magnetic poles of a solenoid? That's what I am teaching. If the current is like going in clockwise, you are seeing, then that end will be south pole. Then one pole if you got, then other end will be what? North, opposite of it. This is the way we are marking magnetic poles of a solenoid. You got the idea? Let me tell you a short trick here, a creative diagram. From letter S, what direction you can mark on letter S? Yes, we can mark clockwise direction. So remember, clockwise current is south pole. That's the idea. Clockwise current is south pole. And from letter N, what kind of direction you can mark? Anti-clockwise current. We can mark what? Anti-clockwise current. Look at this. If the current is like an anti-clockwise, then that end will be taken as north pole. Keep this logic in your mind, okay? Once you got the magnetic poles of a solenoid, then we can mark magnetic field lines. How do we draw the magnetic field lines? Magnetic field lines. See, magnetic field lines, if it is south, magnetic field lines will be merged. And magnetic field lines of a solenoid, you know, it is exactly similar as that of bar magnet. Then how the field lines, you know, the magnetic field lines of a bar magnet, right? So it will be like this. Then how do you mark the arrow? That's actually the requirement of to know magnetic poles. If it is south, then it will be converges. If it is a north, magnetic field lines diverges or emerge. Okay, so this is the magnetic field lines of a solenoid. So through this diagram, I teach how do we mark magnetic poles of a solenoid. Got the idea, right? So that's the first part. Bar magnet also. Bar magnet, magnetic field lines. Let me draw the bar magnet, magnetic field lines also here. North and south. It will be like this, right? Let me draw the cube diagram. It will be like this. Now, what is the difference between these two fields? Difference number one. Bar magnet is a natural magnetism. It has natural magnetism. It has a permanent magnetism. You can't change the magnetism of a bar magnet. But solenoid magnetism, we can change. What are the way in which solenoid magnetism we can change? Pause the video and think. Yeah, if you change the current in the solenoid, magnetism can changes. It becomes weak magnet, it becomes strong magnet, like that. If you alter the current or if you alter the number of coils, you can change the magnetic field strength. That are the two ways. Got the idea? Yes, what are the way in which we can change the magnetic field? Either by changing current or number of turns or by putting something inside. I will tell you that. That's my next question. Okay, so the comparison, what's the feature? Solenoid magnetism, we can alter. We can change the magnetism of a solenoid by changing external factor. But in bar magnet magnetism, we can't change. It is fixed. Once you purchase a bar magnet, in magnetism, we can't destroy and we can't alter. That's the first comparison point. Second comparison point, magnetic poles of a solenoid can be changed. We can interchange. That is, when it becomes south pole here, when the current is clockwise. If you set here the current is anti-clockwise, then here it will be what? North pole. How can you do that? By changing the terminals of the battery. Just to reconnect the battery. Okay, if you keep here negative, then current automatically changes the direction. Whenever you changes the direction of current in solenoid, magnetic poles also got changes. But what about here? Magnetic poles are fixed. This end is always north. It's very boring, right? Bar magnet is very boring because all the time one end is always north. North can't make like next second act like a south. But here, no, so flexible. It's like very interesting, right? Like one end is north, then you can make what? It's not boring. This end never bore because next time, you know, he can make what? This end is south. So what's the long story short? So what's the comparison between long solenoid and bar magnet? The point is that the field of two, what's the comparison? Point number one, we can change the magnetism of solenoid by changing the external factor. But magnetism of bar magnet we can't change by changing external factor. Point number two, magnetic poles of a solenoid can be interchanged by reversing the direction of current. But magnetic poles of a bar magnet is permanent. We can't change. Okay? And one more additional point I will say, magnetism of a solenoid bar magnet will be permanent. You cannot destroy. But here magnetism of a solenoid, we can destroy by switch off the circuit. By turning off the circuit, then what happens? Current disappear, magnetism disappear. When current comes, magnetism comes. So in solenoid, it shows magnetism how long current exists in that solenoid. You got it right? Keep in your mind this all stories is very important part of you. All right, let's move to the next question then. And this question is based on electromagnet, which is also connected to solenoid. Listen, what is electromagnet? Another definition needed point. What do you mean by electromagnet? Yeah, whenever they ask electromagnet, you can write a coil of copper wire wrapped on the top of soft iron core. A coil of copper wire wrapped on the top of soft iron core. That is simple. Like we have a solenoid. Inside the solenoid is what? Empty, right? Here it is empty. So this is what you call solenoid. Fine. Now if I keep like a material which is called a soft iron. It is called a soft iron inside. I am filling some material inside. What that material called to be? It is called the soft iron. It doesn't means that is soft like a pillow or soft like a Rafi sir. It means it can be easily magnetized and demagnetized. So what is soft iron? A material, a type of iron in which it can be easily magnetized and demagnetized. We can quickly magnetize and quickly demagnetize. That's what we call the soft iron. Keep in your mind, I think that question is asking here, the purpose of soft iron. So I answered here, I give you the answer here. What is the purpose of soft iron core inside the solenoid or in electromagnet? It can be easily magnetized and demagnetized. That's the answer of the C part. Okay, wait. So what is electromagnet? This is called electromagnet. So electromagnet, I can write shortly to you. Electromagnets are basically soft iron plus solenoid. Soft iron plus solenoid. What is inside the solenoid generally? Empty. Like a chapati roll only. But here electromagnet is basically inside the chapati roll there is a chicken leg piece is staying. That is what we called electromagnet. Keep in your mind, okay? Yes. So that's actually electromagnet. Oh, what is the use of electromagnet? I'll just show the use of electromagnet at the end, okay? But here they're just asking only what's the use of electromagnet. Where electromagnet used? Electromagnets has several applications are there. So let's just listen two of the applications for getting score, okay? What are the uses of electromagnet? Number one, it is used in electric bell. Where it is used? Is used in electric bell. Not on the answer, it's used in electric bell. And loudspeaker, you can see electromagnets. Loudspeaker and electric motor, electric motor also contain what? Electromagnet. At least remember these three devices. What are them? Electric bell, then loudspeaker, then electric motor. Keep in your mind. So the first part is fine, right? The first part is okay, right? Look at the B part. Draw the label diagram to show how electromagnet is made. This is the label diagram. Label diagram means you can write like here what? Battery. You can write here battery, and there is a key, and there is a soft iron. This is a coil, okay? It's called coil. So this is what? Soft iron. You can make it a little more beautiful. So that's the B part. Then what about C part? C part I already given the answer, right? So what is the purpose of soft iron core? It can be easily magnetized and demagnetized. Okay, fine. List two ways. Look at the D part D. List two ways increasing the strength of electromagnet. How can we make this electromagnet is like more attractive magnet, more strong magnet? What's the idea? The number one, the point is, let me write here. I'm giving shortly here. Increase the current, right? Increase the current. Increase the current. Don't write exam like this, okay? You just write in word completely. Electric current should be increases. When you increase the current, then it become what? Strong magnet. Then what's another idea? Increase number of coils. Sorry, increase the number of turns. Increase the number of turns. If a solenoid, you can make you can make a short solenoid which contain less number of turns, and you can make what? A solenoid contains many turns. Then what's the difference in this? Yeah, this act like a very strong magnet. It's like a weak magnet. So what are the two ideas? Increase the current, increase the number of turns. That's the idea, okay? So you got this right. It's one of the previous year question. Keep in your mind this. All right. Now let me explain very quickly the electric bell working through this circuit diagram. All right. So see the circuit. What is the main element present in this electric bell? Can you spot on? That is electromagnet. This is what we called electromagnet. So to run current to the electromagnet, we have a battery. So when the switch is on, this electromagnet become what? A magnet. Then it will attract this soft iron. So when the soft iron goes up, the striker goes hit on this gong. That's make a feel where a sound. Tum tum. The ringing sound of electric bell. I'm not an artist. Okay. So it makes a sound. That's what we called electric bell is ringing. All right. How simple is, right? But it's a brilliant technique. Then when strikes here, then what will happen? When it strikes there, then you can see this, when the striker goes up, the circuit is broken. The circuit loses the contact here. Earlier, it's connected here. When the striker goes up, it loses the contact. Circuit become open now. Battery is not longer sending current now. So this is not an electromagnet now, current carrying electromagnet now. So it become demagnetized. When there is no current, electromagnet become demagnetized. When it demagnetized, then this attraction is no longer exist. So what will happen? The striker goes back, the sound stops. Got the idea? This is what the working of electric bell. How simple is, right? But it's a brilliant technique. You got the idea? If you hear anything to say, please let me know in the comment box. Stay tuned on this YouTube channel. Obviously, we need your comments and like. Thank you so much. Signing off, Rafi sir, physics teacher from Excel Education Center. Bye-bye.